All right, today we're going to learn how to solve exponential and logarithmic equations. Oh, there's my calculator. All right, we'll need that a little bit later. So, what our first method, we're going to talk about 4 different methods today of how to solve exponential and log equations. 2 methods for exponentials, 2 methods for logs. They're very similar though. So, method 1 for exponentials is make the bases the same. So, right now, in number 1, we have a base of 5 and a base of 25. Well, since 25 is 5 squared, I'm going to rewrite it as 5 squared. And that's being raised to the x minus 6 power. And this is 5 to the x minus 4. Now, hopefully you recall from Algebra 1 that when you raise a power to another power, and actually we talked about this briefly last class, power to another power, you multiply. So this would become 5 to the x minus 4 equals 5 to the 2x minus 12. Well, if the bases are the same, what do you think you know about the exponents? They also have to be the same. So we know that x minus 4 has to equal 2x minus 12. Now we do some Algebra 1. Move the 12 over here, subtract the x over here, and we end up with x equals 8. Ta-da! Let's double check it on our calculator. Store 8 for x, and we have 5 to the x minus 4 power, and that gives us 625. And if we have 25 to the x minus 6 power, we also get 625. They're equal. Excellent. Well, let's move on to the next one. Now, this one isn't as easy because we're going to have to change both of our bases. We have an 81 and we have a 1 over 27. So I'm going to focus on the 27. Let's look at our power chart. Is there a column that has both a 27 and an 81? They are both powers of 3. So we're going to rewrite both these exponents as powers of 3. So 81 is 3 to the 4th times 3x minus 1. Remember, if we're going from a fraction to a whole number, the exponent is going to have to be negative, and 3 to the 3rd is 27, so it'll be 3 to the negative 3 times 5x minus 6. So now that our bases match, we can ignore them. I'm going to go ahead and distribute at the same time. I'll have 12 minus 4x equals negative 15x plus 18. Then we're on to some Algebra 1. I'm going to move 12 over here and add 15x over here. And we end up with 11x equals 6. And if we divide both sides by 11, we get x equals 6 over 11. So let's store it and see if we're right. There we go. So 6 over 11, store for x, 81 to the 3 minus x power gives us that big decimal thing, which is fine. Let me use the parentheses, alpha y equals, enter, 1 over 27 to the 5x minus 6 power, and they come out to be the same decimal, which means this is our answer. Excellent. So that's method number 1. Method number 2. We don't have two bases to match up. We cannot make 7 into a power of 15 or 15 into a power of 7, nor are they both powers of the same base. So our next option is to rewrite in log form. Okay. So you guys did this with your properties of logs. This would become log base 7 of 15 equals 9x. To get x by itself, we would divide by 9. So x equals log base 7 of 15 over 9. Now, the nice color calculators that are in my class, you can do it just like this, and I'm going to show you guys how to do that. If you're using an older calculator to find out what our final answer for this is, you're going to have to use the change of base property that we talked about. So that would become log of 15 over log of 7 over 9. Since you guys will be using my color calculators most of the time, if you want log with a base of 7, you can't just push this button. That's common log, that's log base 10. Natural log's right below it. We have to do math, and if you push up to get to the bottom of it, where it says log base, choose that, and it'll give you the little blanking box to fill in where the 7 goes as our base. Then the 15 goes in the parentheses, and then we're dividing that by 9. Now, logs are irrational numbers. If you try to do math enter enter, it's not going to change it at all. So, you need to make sure you know how to round and that you're rounding correctly, and we're going to round to 3 decimal places. So, if we're rounding to 3 decimal places, we look at the 4th number. It's a 6, so that means we're going to change the 3rd number and it'll become 0.155. And that's your x value. Now, the nice thing is on the right hand side we have a whole number. So we only have to check the left hand side. If we do 7 to the, let me store this. 0.155 was my answer. Store for x. And I do 7 to the 9x power. I should get 15. Well, I get 15 with all these extra decimals. The reason is because we rounded. Okay? So if it's off by a little bit, that's going to be fine. Just make sure you round correctly to 3 decimal places. All right, this next one. Think back to a lot of things we've done. If we wanted to square root both sides, we had to make sure the x squared was by itself. When we wanted to solve absolute value equations, we had to make sure the absolute value was by itself. What other ones have we done? Just in general, when we wanted to solve, we had to get the thing with the x by itself. Same idea here. So we're going to subtract 16. We're going to divide by -3. Now that we have the part with the exponent, we're going to rewrite in log form. Now, normally we would write log base e of 3 equals 2x. Except for we know from our properties that log base e is written as natural log of 3, and then we're going to divide both sides by 2. So on our calculators, natural log of 3, close the parentheses, and divide by 2. Make sure you close the parentheses. We want to take the natural log of 3 and divide it by 2. If you don't close your parentheses, the calculator is going to find the natural log of 3/2. And it's going to be a much different number. So this equals 0.549. We're not changing the 9 because the 4th number was 4 or lower. if you want to go back on your calculator and check, -3. Then if you do second natural log, that'll give you e to the x power. Oh, sorry, I forgot to store. I'm getting ahead of myself. Store for x, then type it in. -3 e to the 2x power plus 16, and we should get 5. And we don't because Miss Pop subtracted incorrectly earlier. Sorry. And this is why we check our answers. This should be -11, and this will be 11/3, and this will be 11/3. So when we type it in our calculator, we'll have the natural log of 11 thirds divided by 2, 0.650, because the 6 here will make the 9 round up to a 10, which would be 0.650. All right, now let's try this again. 0.650, store for x, -3 e to the 2x power plus 16, and we should get a answer that is very close to 5. And that rounds up to just about 5. So we're good to go. All right, so those are our 2 methods for solving exponential equations. Now we're going to move on to solving log equations. So, method number 1 for solving logs, make the bases match. And actually, these tend to be students' favorites because they're the easiest. You don't really have to make them match. Either they match or they don't. So, log base 5, since they match, we can ignore them, and we get 4x minus 7 equals x plus 5. Subtract the x, add the 7, and we get 3x equals 12. Divide both sides, we get x equals 4. So let's check these out. We do, nope, we want log base, so math, go up to log base. I didn't store again, sorry guys. 4, store for x. Math, go up to log base 5 of 4x minus 7, and that gives us that decimal. So math up to log base 5 of x plus 5, and we get the same decimal, so we're good to go. So, same thing applies if they're both natural logs. They're both natural logs, we can ignore the log part and just worry about what's inside. So, now it's basic algebra 1. Subtract the x, add the 7, you get that 3x equals 18. Divide both sides by 3, x equals 6. And for the sake of time, I will tell you that that one works as well. Now, the thing you have to be careful of when you're taking logs, if this inside part, say x was 1, that would be 4 times 1 is 4 minus 7, that would be the natural log of -3. Remember we said when we did our properties that you can't take a log of a negative number. It's not defined because we can't raise something to a power and get a negative number. So you have to be careful that this inside part doesn't simplify to a negative. All right, method 2. If we don't have logs on both sides to ignore, we're going to have to rewrite in exponential form. And like many other things, we have to make sure the log is by itself before we start. So in number 7, log base 4 is on this side by itself. So we can rewrite in exponential form. We'd have 4 to the third equals 5x minus 1. 4 to the third is 64 equals 5x minus 1. We'll add 1. 65 equals 5x. Divide both sides by 5. X equals 13. If we plug x into this parentheses, are we going to get a negative number in here? No, we're in the clear. Number 8. Let's get the natural log by itself. We're going to divide by 5. We get the natural log of x equals 7. So if we rewrite this in exponential form, we would get x equals, remember the base for a natural log is e, and then to the 7th power. So we're going to go ahead and put this in our calculator. E, remember, is second natural log to the 7th equals 1096.633. So if you get a really big number, make sure you're putting commas in where they go appropriately. Now sometimes we have 2 logs on one side, and we can't just ignore them because that's not the same as what we had before. On both of these, the whole side was inside within the log. This whole other side was inside the log. Here, we've got a plus sign in between, and the other side doesn't have one. So when we talked about our properties, we learned ways to condense 2 logs into 1. Since this is addition, we're going to condense by multiplying. So we'd have log. We're going to multiply 5x with x minus 1, which would be 5x squared minus 5x equals 2. And now we can rewrite this in exponential form. So we'd have 5x squared minus 5x. Since this is common log, we know it's a base of 10 to the 2nd power. I'm just going to simplify. Now, think back. We have x squareds and x's. In order to solve this, we're either going to have to factor, complete the square, or use quadratic formula. The nice thing I'm going to tell you is all the ones that I give you with this stuff, you are able to solve by factoring. So we're going to bring over the 100 to the other side in order to make it equal to 0 so we can factor. Conveniently, all of these are divisible by 5. So we get x squared minus x minus 20 equals 0. What 2 numbers multiply to negative 20 and add up to negative 1? That would be x minus 5 and x plus 4 equals 0. So we get that x equals 5 and x equals negative 4. So let's check this out on our calculators. Let's do 5 first. 5 store for x. So we have log of 5x plus log of x minus 1. And hopefully this comes out to equal 2, which it does. Excellent. Now let's store negative 4 for x. So I'm just going to go up and I'm going to copy and paste our equation from earlier. And what happens when we store negative 4? Non-real answer, because 5 times negative 4 is going to be negative 20. We can't take the log of a negative. So that means negative 4 is an extraneous solution. So 5 is our only answer. Now be careful. Just because this answer was negative does not mean that it's going to be definitely extraneous. You have to check by plugging it in. Let's look at one other equation where we have to condense before we can rewrite. Here, again, we have 2 logs on the same side, but before we can condense them, we're going to rewrite it as division this time because it's a subtraction problem. So log base 2 of 10x over x plus 2 equals 3. Now we can rewrite this in exponential form. 10x over x plus 2 equals 2 to the third power. I'm going to simplify 2 to the third as 8. Now, we got this fraction over here that we can't simplify. So in order to get the x plus 2 out of the denominator, I'm going to multiply both sides by x plus 2. Here they'll cancel out. So I'll be left with 10x equals, make sure you distribute the 8 here, 8x plus 16. So I'm going to subtract 8x, subtract 8x, and I get 2x equals 16. Divide both sides by 2. I get x equals 8. And if I plug 8 in here, 10 times 8 is 80. That's good. It doesn't break the negative rule. And 8 plus 2 is 10. So we're good there too. That's all for today. See you in